Hello, everybody. Thank you for joining us. We are excited to have you with us here today. Welcome to our webinar. This webinar is Optimizing HPC Spend and Performance, where we will discuss the pillars of HPC optimization and how IT departments can build a robust and secure continuous optimization engine for their compute workloads, whether they are on-premise or in the cloud. My name is Jolie Hales. I'm with Rescale, and I will be your moderator today. We also wanted to make you aware that the next Rescale webinar will take place next week on November 19th, and that will focus on enabling large-scale multidisciplinary design optimization using the cloud. And there we will get to talk to Professor Joachim R.R.A. Martins from the University of Michigan's Aerospace Department, which is supposed to be really cool. He will share his perspectives on the promises and the challenges of MDO, and he'll also get to share with us some of his lab's cutting-edge MDO work in aircraft design, so that should be a lot of fun. We'll also see a demo of an MDO airfoil analysis that's leveraging ADFlow CFD solver, as well as machine learning-based surrogate aerodynamic model trained and deployed on the Rescale platform. So lots coming up. Again, that webinar will be on November 19th. And if you know somebody who's interested or you want to join us, you can find registration information for this webinar and any other upcoming webinars on rescale.com or on any of our social media channels, including LinkedIn. And you can also find many of our past webinars and other helpful videos on Rescale's YouTube channel. So feel free to take a look and subscribe there as well. Okay, without further ado, let's go ahead and get started. Our presenter for today is Ed Hsu, and he is the Vice President of Product and Marketing at Rescale. Now, a little bit about him. Before joining Rescale, Edward ran product and marketing at D2IQ, which is formerly known as Mesosphere, as well as he also ran product marketing at VMware. Earlier in his career, Ed worked as a consultant in McKinsey & Company, and he served as an engineering lead at Oracle's CRM division. Edward has a master's and bachelor's degree in electrical engineering and computer science from MIT and an MBA from NYU Stern School of Business. So he's, on a personal note, Ed is a great guy, superhuman, and a lot of fun to talk to. I think you'll really enjoy his presentation. So without further ado, I will go ahead and turn over camera time to you, Ed.
Awesome. Thanks, Jolie, for the fantastic introduction. Really a pleasure to chat with you all here today and talk about HPC. A little bit about my perspective on high-performance computing. It's clearly a discipline that has a long storied history. We've seen in recent years a lot of innovation advancements around bringing service operations discipline to broader enterprise IT. And I think now it's time for this to happen in the HPC space. And that means better managing, better measuring, and then optimizing performance overall. So we're going to get into that today. What I intend to share is just kind of a recap of the challenge we have in the HPC industry, some of the shifts in the industry that have been happening that really gives us a new opportunity to think about performance management differently, and then share our approach to tackle this problem. It's clearly not a very simple problem or would have been solved already. And then how are we trying to operationalize this for some of our customers as they try to roll out this data-driven approach to full stack optimization. So let's get going, and happy to answer questions as we roll through this. So when I first arrived at Rescale, I looked at where we were in terms of cloud adoption. And it was interesting. In 2019, Hyperion Research, one of the leading analyst firms in the space, talked about 2019 being the year where it's no longer a question of whether we're going to cloud with HPC, it's a matter of when and how. And it reminded me of another number when I was at VMware back in 2010, which was also around roughly 20% of the workloads, so being in cloud. So there's a shift that I see that's pretty in parallel between HPC, which is typically science and engineering workloads, and what's happened in the CRM, ERP, mobile cloud space. So roughly speaking, we're about a decade behind in the shift towards digital transformation, of which cloud is a part of. And I think the reason why broader enterprise IT saw shift to cloud much more quickly was because obviously the virtualization technology that make workload portability more practical. The fact that cloud providers had a lot of commodity infrastructure that they were starting to rent out and share. And then, of course, the advancement of SaaS and open source software, which made it very easy to build cloud-based services using all the cloud service providers using the x86 virtual infrastructure. Now, if you look at the R&D space, things are a little bit different, right? The workloads are a lot more specialized, the hardware is a lot more specialized, and the overall stack is just more complex. And not to mention, a lot of the software being used in our space is there's some open source software, but a lot of it's actually commercial ISV software that tends to be sold in terms of a perpetual license basis. So it's not going to be as easy for you from a business perspective to say, I'm going to run this as a utility-based resource. But I think a lot of that's shifting 10 years later. Today, pretty much all the new specialized architectures in HPC space are available from the cloud providers as quickly as you could possibly buy them as a HPC organization, right, from the hardware vendors. A lot of the software vendors, a lot of these are folks that we at Rescale work directly with, are actually starting to offer utility license models for their software. And then lastly, having cloud management platforms and automation layers, Rescale is an example of that, bring it all together. And because of all these factors, and a lot of it's also just the sentiments of the HPC leaders, a lot of people believe that in this, that practice HPC believe that a lot of the workloads, 50% of the workloads, will be moving to cloud in less than 5 years. So we're at an inflection point where cloud is very relevant now for HPC. The foreseeable future will of course be hybrid, and I can share a little bit more on why we think that's the case. But it gives us a new opportunity, right? Because today, the traditional HPC approach, it's really just been about figuring out what's the right architecture, right? What type of workloads do we think will run? Let's go buy a lot of that architecture. Let's make sure it's got high utilization. And when it's time to refresh the hardware, let's refresh the hardware. That's if you talk to HPC leaders, and I spend a lot of my time doing that, although a lot of us talk about wanting to accelerate innovation for R&D, when you break it down to what are the day-to-day worries and concerns of these HPC leaders, it's a lot around these things, right? And maybe a little bit around software as well. So what this means is, as much as we want to focus on helping the business accelerate innovation, we're actually very focused on the hardware, right? And the hardware acceleration has seen a paradigm shift, if you will, right? A lot of us have read about Moore's law slowing down, and the innovation of many new specialized hardware technologies are helping to offset that slowdown Moore's law with specialized architectures. But what does that mean? It means now that when you're running workloads, you have to know what architecture would be best for that workload to get that same benefit that previously Moore's law just kind of gave us for granted. And the recent evidence in cloud advancements in new architectures is clearly accelerating, right? So it used to be AWS dominated the space, not just cloud computing, but also HPC cloud architectures. But now Azure, Oracle, Google are all making a lot of investments. So there's a lot more choice. There's a lot more performance. But that's the upside. The downside is there's a lot more choice, right? And there's a lot more things to manage. And so we need to find a way to ideally automate all of this. Our new opportunity, of course, is going from a world where you're buying the hardware and then just running your software based on that hardware decision and just taking the performance improvements or penalties based on that decision, to one where you start off with a workload, right? And then based on the workload, performance characteristics with the various hardware that's available out there, you choose the right hardware for it, right? So that's ideally what we can all do as an industry. So we're choosing the best architecture to run your workloads for the best performance, for the best economics. But it's not as straightforward as just moving an arrow from right to left to right, right? There's a lot of things that are also happening. Of course, we have as HPC leaders, we have business leaders, stakeholders, if you will, that are pushing us to give them the ability to bring products to market more quickly. Requirements are always changing as we start looking at organizations that are starting to consolidate some of the HPC infrastructure and cloud capacity. How do we manage demand between different organizations, right? And because HPC is a fairly complex discipline, it's not just about is your database up and running, right? Is your server up and running? is my web service up and running? It's about these simulations we're trying to run. What are the bottlenecks? Where are we getting stuck? My job is not working. Is it because of the job setup? Is it because of the hardware? Is it because of something around the network? Trying to solve for that business outcome for the end users is very important. And of course, we want to do this securely. So that's just how we service our clients, right, within the enterprise. Then there are internal things that we have to think about in HPC land, and of course, that is the broader workload mix that we're starting to see. Right, people are starting to run simulations at more and more disciplines. I just talked about new architectures, and knowing which architectures to use at what point in time. Not a very straightforward problem to answer, and especially now as we're all working from home and working remotely, and many organizations have offshore R&D locations. How do we ensure the application of best practices, whether it's around how data is being stored or how a simulation job is getting set up, or how data is being passed between simulations as part of an overall computational pipeline? Those are all things that ideally we can standardize and facilitate to help our clients, the engineers and the scientists, work more productively. Hybrid cloud, of course, is a operational reality for many HPC organizations today. I think it's going to continue to grow. And then we have to do all of the stuff I just mentioned around business challenges and internal challenges while maintaining a very efficient operating model, right? Because managing cost and performance is always going to be top of mind for IT leaders. And so how do we do this? That's kind of the challenge. And we think we believe the right approach is to extend what's been known in the industry as software-defined computing and add performance intelligence to it. So what do I mean by that? When I worked at VMware, I spent 5 years there, many good years. What was very clear to me is that at a company like VMware, we think a lot about virtual infrastructure. That makes a lot of sense. We don't think about the hardware very much, right? In fact, hardware was something that we, and I would argue the entire cloud-native ecosystem world, thinks of as just commodity, right? The hardware, the saying is hardware will eventually fail, software eventually becomes perfect, so we're just going to focus on the software. And I think when you're building what I call connectivity-driven innovations, right? You're doing lookups on the database, you're trying to match records, you're maybe doing some light processing on the data at scale, that works. But when you're trying to do numerical methods, you're trying to do a lot of computationally intensive, high interconnect type of workloads, you don't want to just use commodity hardware. You want to use the right hardware for the right workload, because that can actually help you get to answer 2, 3, 4 times faster, right? Or even more. And so what we're doing at Rescale is taking our expertise in HPC and adding that soft performance intelligence to software-defined computing. So our users, our customers, our researchers can get any computational power they need and make sure on the right hardware for the best performance. That's kind of the one half on the top piece here. The other part is when you have this capability, you can start doing interesting things like digital R&D, right? Think not help R&D organizations just run a job faster, but better understand the overall computational pipeline, the overall objective of a project, and do everything from improving the economics and performance, but also improving collaboration and R&D innovation, through better management of the overall workflow. So that's the way we think we can really help. And I'm going to walk through in this next section how we're trying to tackle this problem around full stack performance optimization. So the way we're thinking about this is to, step one, structure the facts. You have points, performance points, maturity, many different aspects to how you want to optimize your HPC infrastructure. And ideally, all that information is synthesized and distilled and can be automated so that your platform can be configured to make those decisions on your behalf, right? That gets to data-driven assessment of options. And then eventually, we want to be able to do this once we build enough experience on this, working with our customers, to be able to completely make this autonomous, right? Imagine a world where any researcher, any scientist trying to run a simulation, whether it be about star formation or molecular dynamics, when they choose their software, the platform will just choose their hardware for you. No matter which cloud, no matter if it's on-prem or cloud A, B, C, D, it's going to find the most performant or the cheapest, whatever your business goals are, and help the researcher get to that answer aligned with business objectives. That's the goal. And the way we do that is to try to break down the problem into a few pieces, right? One is establishing a way to synthesize the performance of a workload for different architectures. Another is, of course, classifying the maturity of the architectures that are available. So one little known thing about cloud computing is that when you're talking about the commodity infrastructure, there's a lot of it and it's very cheap, right? When you're talking about specialized architectures in the world of HPC, things are a little bit different. Number one, the workloads are using specialized architectures, and there's just less of those specialized architectures around, right? There's far less capacity on a specialized HPC architecture than there is for your generic compute architecture on Amazon. That's kind of one. Two, the workloads are very spiky, right? So when you're a researcher trying to change a design for an aircraft, you're going to all of a sudden go from very few cores to all of a sudden 30,000 cores concurrent because you want to solve that thing. So the spikes we see in our industry for this application is a lot more than your typical e-commerce, summer lull versus Thanksgiving versus Christmas, right? And so those are just some of the examples of how our space is quite different than the broader e-commerce space. Another one is when you're using HPC, if you run a cluster, you can't have a lot of those servers fail, right? In a hyperscale architecture commonly used for e-commerce, like if you lose a few servers, you're built up in microservices, so it's not a big deal. But if you're running a numerical method and you're running a lot of servers, you're doing HPC, you don't want too many servers to fail. In fact, that can actually mess up your entire job, and you're spending a lot of money to solve that one job. So that's the difference. That's why maturity and scale really matter. And of course, cost. You never want to pay more than you need to. And so what we did was basically take the fact that we at Rescale do a lot of benchmarking all the time for many of our customers, and the insight was, well, you don't always need this level of detail. Sometimes you just need the synthesis of these performance curves, if you will, into specific numbers, building up a data model that can classify what is the performance at various scales for specific workloads. So then you can, at runtime, at job submit time, know with reasonable accuracy what's the best architecture, what's the best scale to be running this job, right? And so the goal is to be able to make those decisions for the researcher automatically so they can get to their business objective. The second part, of course, is the maturity. And so what we've done is develop this, at Rescale, we call it the Rescale Maturity Index, and something we use internally to know when to recommend a particular core type for you. And so when a new core type comes out from a cloud provider, they might say, hey, we have a new infrastructure. We're excited. We want you to use it. We want the world to use it. And then when you start using it, you realize, okay, they're still building out their capacity. So they can give you maybe a few thousand cores concurrent, but you can't get 30,000 cores at the same time. It's just not, the capacity is not there yet, right? But there's not much marketing literature out there to tell you that's this current situation. But at Rescale, because we're helping all of our customers run these new architectures, we have a sense of what's the mileage, what's the capacity, and what's the defect rate when you're launching these infrastructures to know whether we would classify it as GA3, GA2, or GA1, which is our most high scale, most mature architectures. Okay, and then lastly, there's the pricing, right? And so pricing is just math. It's not that complicated. So what you see here is a simple screenshot of when a simulation engineer is trying to run a job. He and she could choose the hardware settings, and then you'll see these are all the hardwares. This is just a double click on the general purpose. There's actually many other groups here. And so these are aggregations of all these core types from all these different cloud providers or your data center. And at job runtime, you can just choose the architectures you want to run, and a cluster will be spun up just to run that job. And when that job is done, the cluster is killed, so you're not wasting money buying infrastructure that you don't need. So that's pricing. You'll see some of the price points here, and that's how we aggregate it. But when you put it all together, that's really when the magic happens, right? In terms of trying to get you to performance optimization. So what you're seeing here is the composite Rescale performance index for all the architectures from the 4 major cloud providers. So it's your big 3 plus Oracle. And what you're seeing here is that CSP1 overall, because it's an older cloud, it's been around longer, it's got a lot more cores. The average performance of their cores in CFD is lower than some of these cloud providers that joined the space more recently, right? And so their newer core types are more performant. This cloud provider also has this one's AWS, by the way. They have a lot of core types that are also very performant, but we're averaging some of the older ones, and that's why it looks lower here. So the point of this chart is not to say CSP1 is worse than the other cloud providers. The point here is to say that the cloud providers do have different portfolios of architectures, and they do perform differently based on the type of workloads you're running. And so if you are an organization running many different types of these workloads, it behooves you to look at the economics of some of these different architectures from different cloud providers, because it can really help you either get to answer faster or save you a lot of money. So that's just an example. If we double click on CFD, this is a breakdown of some of the architectures and what is the relative performance of the most performant versus the least performant of that architecture, right? So roughly speaking, if you made the perfect choice, you're running at 100% speed. If you chose the worst possible core type available from the catalog, you're running at 1/10 as quickly as if you chose the best one in this scenario. So that's performance. Now let's add maturity. So the maturity index changes over time for a given core type. When a new core type comes out from a cloud provider, right, a new instance type, and Rescale configures them and we call them a core type, it's not yet mature. So we call that in here maturity, MAT4, right? So MAT4 is basically a core type that is in beta, and then MAT3 is GA, MAT2 is GA with even more scale, and MAT1 is the highest scale, most mature core type in our catalog. So you can see here that the performance index for our most mature core types tend to be less performant than the new ones, which makes sense because cloud providers are onboarding new core types and making them more performant, right? And bringing them to their marketplace. And so you'll see here that the latest generation of core types are roughly 20% more performant than the ones that have been around for CFD, right? And then in some of the other spaces, the performance might vary over time. But generally speaking, the newer ones, the less mature ones, are more performant. And then over time, a lot of the ones that are at maturity 1, over time, they actually get retired by the cloud provider. So in that case, we actually rotate the maturity scores away so that if you're looking at our data points, you don't have to worry about that migration plan. Rescale will do it on your behalf. Okay, now let's add price to all this, right? So if we take those numbers I talked about earlier and we score them around, bigger is better, right? Or a higher performance index means that it's going to run faster. Higher maturity index means it's more mature and it has more capacity. And then the value is basically how much RPI or how much performance you can get per dollar or percent, right? And what's interesting here is if the decision for your organization on which type of architecture to choose will actually be very different based on what you're optimizing for. For example, if you are an organization that's using primarily open source software for HPC, you just want highest value, right? You want the highest possible number of compute cycles per penny that you're paying. If, however, the economics of your HPC practice was largely around this much hardware spend for that much software spend, then sometimes it actually makes sense to pay for more expensive hardware because that performance increase, even though it may not be as big as you like compared to the spend, it might actually reduce the overall software spend. So here's a real example. If I told you there's a new architecture available from one of our cloud provider partners, and it is 3 times more expensive, but only twice as performant, normally you would go, that's not a good idea. I'm not going to go buy that. But if you factor in the fact that a particular workload you're trying to run, the software is 7 times more expensive than the hardware, then all of a sudden it might make sense because by using that hardware, you're having your software spend, right, from 7 to 3.5 compared to the hardware. So those are all decisions that will really vary depending on the type of workload and the architecture. And this is why we think a data-driven approach helps to get there. And I have an example of how that looks in just a minute. Lastly, on the lower left, sometimes you are running at scale. So some of our large customers, especially in the automotive space, they need to run concurrently 10, 20, 30,000 cores in aerospace space. And so it almost doesn't matter what the value and what the performance is. If I can't get the scale I want, that's not going to be very useful for me. So bringing these together and structuring this allows us to help our customers make some good decisions per application, not just the monolith stack of infrastructure. Okay, so the way we synthesize that is what we call these things is this thing called the Rescale Performance Index, the Rescale Maturity Index, and then you put the the performance index over hardware costs, and that gets your overall estimate of value. So let me walk you through what that looks like when we operationalize it. So what I just shared so far is basically some of the work we've done in the last 18 months to establish that intelligence, take all the benchmarking work we've been doing for years, and then turning that into a useful data model that we can use to essentially get to a expert system, right? To make recommendations on architectures. And so, to get the most out of this, we have to make sure that we think holistically, right? And so one thing that I like to challenge us as industry to think about is it's not just about the hardware, right? So oftentimes we think about, let's get cheap hardware. Oh, then let's get cheap software. And then let's see if we can help people out with their workflow automation and helping them access data more easily. I actually think that's that might have made sense at one point in time, right? When the hardware decision is not something you can switch very quickly, right? You could probably change people. You can hire and fire people within 5 years, but you typically wouldn't switch out hardware in less than 3 to 5 years unless you had a strong reason for it. But today, that's very different. Today, you can use your on-prem hardware, but you can also use any hardware in the cloud. So you actually have flexibility on what you want to have, consistency on versus flexibility on. And then, of course, software increasingly getting to on-demand licensing models. Even if you can't, there are ways to do software license queuing so that you get the most out of your software spend. And so, starting from the people down versus the hardware up is an approach that I really like to see if our industry can really push forward. To make all this possible, of course, you want to get to a more modern software-defined approach to running HPC. So just like what's been happening in the broader enterprise infrastructure space, where software-defined computing has now become largely the standard of how people are running infrastructure, we can do that for HPC as well. And not only talk about software, hardware, performance, intelligence, which I just walked through at a high level, but also the pricing, the budgeting, the user intelligence, and obviously the security compliance intelligence, bringing all that together, and then giving IT leaders the ability to make decisions and set policies towards their business objectives. So the 3 pieces I'll talk about on these outcomes are around performance, around control, and lastly, wrapping up with empowered R&D, because ultimately that's why HPC exists, right? We're not here to fool around with servers and software. We're here to help engineers and scientists get to their outcomes, right? The first piece, of course, is around cost and performance, so we'll dive into that right away. So I mentioned earlier that getting to a data-driven approach around assessing performance, maturity, and price is important to help us automate this workload-centric optimization of performance, right? And how do we do that? Well, I think it's not very different than what fighter pilots call a OODA loop, right? You start with observing what's going on, you assess the options, you make a decision, and then you start that process over again. And what we've done with the Rescale Performance Index, Maturity Index is operationalize that and automate that into our platform. So what you're seeing here on the far left is an organization overview. This is all your different business units, what software and hardware they're using. And then you can double click into it and you'll see a performance dashboard. I'll zoom in on this in just a minute. But just to give you an overall flow, you look at which workloads are you spending the most money on, right? And just like how you would optimize your checkbook or family budget, you would go, okay, I'm spending a lot on this one thing. Let me look at ways I can improve that. So you click on that and you look at, okay, what are the other options for me to think about how I can run this workload more efficiently or more quickly or whatever matters to you. And after you make that decision, you define policies either through templates or through our API to say, from now on, anybody that is using ANSYS, this software must use that hardware, right? And then you enforce it. And then if it's a good decision you made, ideally you would see your budget start or spend on that piece of workload start to drop, at least relative to individual jobs you're running. And then when a new performant core type comes in that changes the economics of the situation, ideally you're alerted to that shift, right? Oh, Google just came out with a new core type that's more performant than the best core types available from, let's say, Amazon, or Azure just came up with new pricing that lowers the actual cost. Maybe you should think about using that. Those are all things ideally people shouldn't be spending time researching. Like, that's all public information. We should be able to like push it to you, and then using our performance intelligence, put that together and make a good decision and move forward from there. So what this looks like, this is a hypothetical example, Acme Inc., right? They're spending a lot of money on Star CCM, right? Their job has been queued 88 times because they didn't have enough software licenses. Maybe we should buy more software licenses, right? They're using a mix of different core type. Amber is a core type from our Azure partner, right? There's other the Carbon also from Azure. Some of these are from AWS. So there's no policy set today. So people are just running whatever architectures they want from all the cloud providers. So you can decide, if you click on Optimize, this tells you, well, let's see. You spent $535,000 between April and October this year. And had you been using only Titanium or only Ferrite, these are all core type names that describe our specific configurations of a cloud provider's instance type that's available on Rescale. This is what the economics would have looked like, right? Now, because they're using a lot of Carbon already, the economics is a little bit closer to Carbon, right? But moving forward, if we standardize on using the cheapest or fastest, in the next 6-month period, assuming that the number of jobs stays the same, you're looking at dropping your spend from 353,000 down to 284,000, right? This is just taking that information, distilling it, helping you make a decision, define a policy, and then moving forward from there. And then 6 months from now, ideally, you look at this chart and it's lower, and then you'll see that instead of Carbon being only half of what you use, it's all of what you use, because in this case, Carbon is the best for that workload. And then you have more money. Well, you either run more simulations with that same amount of money, or you take that money and you invest it in other aspects of your HPC stack. So that's an example of a full stack economics optimization, talking about the performance index, maturity index, pricing, bring it all together, helping you make a useful business decision. Now, obviously, power is nothing without control, right? And so as IT leaders, you're oftentimes thinking about, how do I not just make sure people are using the most performant architectures, but that the right people are having the right access to run the right number of jobs or simulations or budgets that they should be allowed to use. And for this, we start with this overall view that Rescale's job is to not be the resourcing plane. That's what cloud providers and your on-prem hardware does. What Rescale does is give you this control plane and taking data and intelligence of how your HPC operations is running and helping you make a decision. So I just walked through the economic example of software hardware stack, but there's other things we can do around your hybrid cloud operating model for multi-team control, security control, infrastructure architecture control. And this is just a high-level view of what that looks like, right? So in this case, Acme Group has a few different business units, right? Some of our large customers use this view to manage different business units. The electric business unit, maybe they don't like the automotive business unit. They don't want to share any data. They don't want to share any licenses. They don't want to share any jobs. That's totally fine. These different BUs can get their own dedicated bills from Rescale, right? That aggregates the software, hardware, and all the costs associated with their HPC operations. Or you can turn on sharing. Or you can actually have members of one workspace also be a member of a different workspace. And the other piece here is that you can delegate admins. This is actually a very important ask for many of our customers, right? If we're a large organization, I don't want to have to do all these like BU-specific configurations or user setups, right? I want to dedicate Jen Ernst here from Acme Electric to administer this business unit. And then I, as Timothy, will oversee security posture, other policies around architectures and budget, but we'll let these BUs have the rights to make decisions that they want to make. Security, obviously, a very key aspect of all this. I just talked about this, and this is a view that's only visible to the organization admin, not the individual BU admin. And so you can set policies around passwords, single sign-on, see data ingress, egress, and see where people are logging in from, right? Where they're doing their research from. And this has actually been a key ask from some of our enterprise customers as well. I talked about economics before, right? This is just another view, right? So you want the financial controls of what architectures get used, but you also want to be able to know how much people are spending by business unit and whether they're over budget or under budget. And you also want to have the ability to say, hey, you get to go over budget because you're a strategic project. You do not get to because you shouldn't go over your budget. And those are all things that you can define on the platform. Okay, so software license controls. I mentioned earlier, software is only one piece of HPC. Hardware is only one piece of HPC. Software oftentimes is far more expensive, right? And so a big part of the ask from our customers is how do we help them with managing, at least number one, getting visibility on their software spend, and number two, trying to find ways to optimize that. So there are ways we can help do that for you, through license proxies, through helping you queue your job so you're getting the most out of your software licenses. And then lastly, as I shared earlier with the continuous performance optimization, like actually helping you make good decisions on, or keeping you alert on like when your innovation cycles getting slowed down because you don't have enough software licenses, and that maybe you should get some more. Okay, and then architecture controls. This is just a screenshot of like if you want to define who can use what hardware, what that looks like. The last piece I'll wrap up with today is just when we talk about HPC performance, spend and performance optimization, right? It's not just about the hardware and the software. It's also about how you can get the best performance out of the people doing the work, right, that are using HPC. And a lot of researchers are not infrastructure experts. And this is why at Rescale, we pride ourselves as an organization. Yes, we do HPC, but we're not just focused on servers and schedulers and infrastructure. We're focused on how do we help scientists and engineers accomplish their goals, right? And working strategically with a lot of our customers that are actually IT organizations or HPC organizations, help them deliver HPC as a service to the business units, the engineers, the researchers. And the way we do that is, number one, we optimize the HPC infrastructure and the software, right? That's kind of a table stakes, I would argue. But on top of that, making it easy for the researchers to do their job through automation, through templates, through improved data sharing, through collaboration. And so here's a simple example. When a researcher logs into Rescale, they don't see all the BU admin stuff that I just showed you in the previous pages. They see this, right? They see, okay, I can right away launch some simulations. I can open up a simulation that's been either created as a template or that's available as a resource, so I can clone it and start playing with it myself and choose more software and just go from there. And especially now that we're all in 2020, when a lot of us are working remotely and not seeing our coworkers in person, I feel like this is very, very salient to our current situation, right? So if you think about whether you're a knowledge worker, whether you're a software developer, whether you're a product designer, a lot of the technologies that have helped these people do their job has shifted from offline packaged software solutions, right, to SaaS-based, cloud-based solutions, right, that are very connected. So an example for a knowledge worker is, of course, your Microsoft Office suite. To today, a lot of us are using Google Suite, right, or Office 365. In the old days, when people coded software, they're checking in their code into some local repository in the enterprise. And now a lot of people are doing that using GitHub or GitLab, right? And they're in the cloud, they're secured, and they're oftentimes managed by IT. However, they're connected, and that allows people to collaborate like never before. And the same is true for software product design. And what I believe is this should also be true is for the simulation space. A lot of the work that researchers do are around computational pipelines. Like what are the steps to simulate chip design, or the steps to simulate design of a turbo, or steps to simulate molecular dynamics, right? These are computational pipelines that are actually quite complex. And what people do today is they draw process diagrams and they publish it, and somehow that's supposed to facilitate me replicating your work so I can push forward on the science. Well, what if all of that was instantly shareable? Not because we're forcing people to use some PLM system, but because when they're running jobs, all of that's already captured and it's very easy to share. right? And obviously you want to do that in a very securely controlled environment, but you have the option of sharing. So that is my view of the direction that we need to be going in, right? To empower R&D, basically digital R&D, similar to how people are thinking about, digital collaboration for knowledge workers, software development. And so in this world of this connected researcher, ideally the software, the hardware, the data, the virtual desktops to do visualization, all of that should be available instantaneously whenever you need it, wherever you are. It doesn't matter what cloud provider you use, doesn't matter where you are in the world, that should be ubiquitous and perceived to be unlimited. Secondly, of course, you want to optimize this stuff. You want to be the best hardware, the best software that you're using, the resource being managed optimally. The third, I talked about collaboration being a key part, and so that's obviously something that we're going to touch on a little bit more. And then lastly, having data intelligence to help you make the best decisions, not just the best hardware, but helping you with what are the parameters I should put to get to the best answer on this simulation, right? There are ways for us to automate that for you. And so that's our goal. Having helped you with economics, having helped you with control, helping you get the most performance out of your organization is also helping scientists and researchers do their job better. So how can we help you fulfill the tools that the researchers need whenever they need it? And how do we make sure that the broader context, all the other information that might be useful for this researcher is actually brought in to help them make those decisions? So a simple view on this, and this is where I'll wrap up, because I know today we're talking mostly about the economics. To wrap up on this, traditionally we talk about HPC as, oh, I got a model, I have a piece of software, I have some data inputs, and I'm going to put it into a queue, and then I'm going to wait for that queue to run that job. When that job is done, I'll find out, and I'll look at how the simulation came out. But we can do so much more, right? When you are a connected control plane and you have all this data from performance to all these other things, there's so much more that we can bring to the table, right? I just talked briefly today about most performant hardware configuration, right? And I also touched on the overall computational pipeline. But there's a lot of other things that we can actually bring to the table. Every job being run is with an end goal in mind. Either you're doing early exploratory research, or you're trying to do final design validation before you go to manufacturing, or you are a lab that's just toying with different ideas. Those are all things that with proper tagging of how these jobs are run, we can actually help our customers really make some good decisions and actually gather some intelligence on what kind of projects are moving through the design and simulation cycle more quickly versus what are the things that tend to slow us down. So I know that's a very pie in the sky, high level view. We could touch on this piece in a future webinar. Today it's really been about performance and optimizing the HPC stack. And so I'll wrap up with just talking about how one of our customers is using high performance computing in the cloud extensively. And they see it as, especially in this difficult economic climate, they see it as their way to really help the company plow forward and drive innovation, even though their resources are not as large as they like it to be, right? So Nissan being that example. So to wrap up, I think we'll continue to see cloud providers pushing new architectures. That's never going to slow down, right? As long as cloud providers exist, they're going to push new architectures. And so if you're one of the folks that think, nope, HPC, specialized hardware, you can't get it in the cloud, I invite you to take a look at what the cloud providers are offering today. Second, of course, a hybrid operating model is going to be the right path forward. For many of our customers, they actually have a lot of experience building, maintaining HPC infrastructure, so that if your workloads are known and the capacity you need is pretty stable, the best decision is probably to keep it on-prem, right? However, that's not always going to be the case. So you have new workloads, you have spiky workloads. How do you complement the on-prem and cloud and do it in a data-driven way? That's going to be certainly an important decision point for you. And then, as I talked about earlier, ideally having a data-driven approach on every workload, on every architecture, that's going to be very important. And then lastly, performance is kind of in the eye of the beholder, right? Some organizations just want it cheap, some want it fast, and maybe there's something in between for different architectures. And that's really going to be up to you to decide. Our goal is to help you get the data, give you the tools to make those policy decisions, so you can actually drive them in your organization and help your company get to science and engineering breakthroughs faster. And that is all I have prepared. Happy to take any questions if any have come in at this time.
Thank you so much, Ed. This has been great. We do have some questions that have been trickling in. So yes, just a reminder, if you do have a question, don't be shy. Feel free to ask it in that question box and we will get to it right now. First question is from Andreas. He says, I liked the statement about digital R&D. How would you envision to connect cloud-based simulation with on-premise-based PLM systems that manage the product data and the 3D models necessary for simulation?
Wow, that is a good question and a very big question, right? So I do think that, how to do it, I think the strategic how is quite clear. The tactical things you do to make it happen, I think, is still playing out in the industry. So I think it starts off with a couple pieces. One, of course, as Rescale, our primary role is to help optimize compute and run those jobs efficiently, effectively. We can basically tag those jobs and then make sure that the data that comes out of those jobs are easily accessible and tagged from the PLM systems, right? I think one of the challenges today is that PLM systems are quite sophisticated, but they require engineers or scientists just do a lot more work to use them. And so how can we simplify that? How can we make sure that by the time you run this job, maybe there's tags from the PLM system that you can put into that job, so people don't have to do any work loading and shifting data all over the place, just to keep the PLM system representative of and not have drift, if you will. Another aspect of this, of course, is having a compute fabric, right, or actually a storage fabric, so that when you're running simulations, it's easy for the PLM system to tag that piece of information coming out from the simulation, whether it be stored in the cloud or on-prem. And so there's definitely a lot of strong linkages we need to build together. And so that's a key investment area for us, and we're investigating that. But nothing specific to share just now.
All right, thank you. We have another question here from Jana. She says, I am not really familiar with the Rescale tool. Most of our users' data is export controlled. Do you support government cloud, and how does that come into play here?
Yeah, that's a good question. So the Rescale platform is basically it's an experience, but we also have the platform. We have several instances of this platform based on different geographies. We also have recently completed our FedRAMP certification, and we have authority to operate, ATO. And so we have customers in kind of the government and defense community, and we're happy to talk more about that in more detail. But additionally, we have control planes in several different geographies, right? So you can choose, for example, to have all your compute and storage always in the European Union all the time and never go outside of that boundary, or you can choose, any combination of the geographies we serve, so that you can ensure that your data only sits in that geography. Your simulations only run in regions from cloud providers in that geography. The one thing we do is give you the ability to switch between cloud providers very easily. Beyond that, all the controls around data sovereignty, around security, those are all things we actually offer a full stack solution for, right? So unlike a cloud provider, we love cloud provider, they're our partners, right? But the model for a cloud provider is more for giving you that infrastructure, and they promise you a secure VM. But what Rescale provides is a full stack security solution. So we don't think of it as a shared responsibility model. We think of it as our job to give you that full stack security. So to wrap up, yes, we do have ITAR by encryption. We recently wrapped up one phase of our FedRAMP certification. And so that is a key area that we focus on.
Great. It looks like we have one more question. So if you do have one that you still want to ask, feel free to put that in here. This is from Richard. Richard asks, what is the Rescale view on distributed cloud so that on-prem systems can be used, like implemented or managed by Rescale? This could feed real-time, low-latency data into systems used, for example, digital twins that need high-performance computations.
Yeah, so at the core of that question is, what is our view on multi-cloud and hybrid cloud, I think. And I don't know how else to say it. It's very core. In fact, 50% of our users, 50% of our customers run on 2 or more cloud providers, right? And it generally reflects the market. We all know the market leader is AWS because they've been in the space the longest. Azure's been making a lot of inroads because they've been pushing very hard on Azure with new architectures. And then obviously, Google and Oracle have recently entered the mix. And so we have customers looking at all these different architectures and using them. And choosing between those architectures is literally as simple as where is that screen, right? When you're running a job, just choosing between these different architectures is how you can switch between cloud providers. So one thing that we care deeply about is giving you the best architecture to run your simulation, and that means giving you the ability to switch between cloud providers. Now, if you care a lot about one cloud provider, and you were to say, hey, Ed, can you filter all these core types so I only see it from my favorite cloud provider? Of course, that's a policy that we can turn on for you, right? And in fact, some of the customers that have been brought in by our cloud provider partners do have that set up because they're very focused on using the portfolio of that cloud provider. However, if you want to look at getting the best architectures out of any cloud, you want to make sure you have that flexibility. Data center, of course, is a very key. For our customers that do on-prem implementations, we're actually currently in beta with several of our customers on this. But basically, you can add your own, Northeast data center or India data center as one of these core types, right? And then you can put in what you think the cost to your organization is, so that when you're about to run a job or when you're setting policies, you can define, well, number one, people can see the cost compared to what's out there in the cloud, so they can make that decision. And then 2, you can define policies to make sure, for example, all workloads from this project must be on-prem, right? Or all workloads from this project will be on-prem except for this one core type in the cloud when on-prem is not available. We even have the ability to define a core type set, so you can say, hey, I'm going to primarily use this on-prem core type, but when there's no more capacity, it's going to burst into this Luna core type from a cloud provider, right? All of this without any work done by the simulation engineer. They just submit, and on the back end, we automate that for you. Now, in terms of low latency data sharing, that's something we're certainly going to need to look into, right? As part of this highly connected R&D world is not just giving you access to knowledge and data about how to run jobs well, but also the data being used by the simulation. And so the answer to this goes back to what is a performant and intelligent hybrid / multi-cloud storage fabric, so that people can use that as source of their simulation and maybe even store some of their outputs there. I know it was a long answer there.
I appreciate that, Ed. It looks like that was the last question that we got in here. So if I don't see any more pop in before the next 60 seconds are over, just wanted to thank you all for joining us today for this webinar. And just a reminder that our next webinar is on November 19th, and you can find that registration again on any of our social channels, especially LinkedIn. You can also find many past webinars on Rescale's YouTube channel and on rescale.com. And yes, it's been a pleasure to be with you today. Thank you so much for joining us, and stay safe out there.
Thank you. Thanks, everyone.